Hello everyone and welcome to the stream. We are just waiting 1 minute, checking that everything works, and then we will start. So make yourself comfortable, grab a cup of tea, and just wait a minute. And let us know actually in the chat if you have like sound, if everything works properly and everything is fine. Thank you. Okay, hi everyone again. So yes, it seems that everything is working. We are online and live, and yeah, let me introduce actually myself and the team. So my name is Vasily Semkin and I'm senior scientist at VTT, Technical Research Center of Finland. And today we have Jarkko Saarinen, he's piloting, he will come in a minute while he lands the drone. And then we have Emmanuel Id, communication manager from ID2Move, who is helping us with the software and like streaming setup. And yeah, the idea for today's stream is just to give you an idea about our drone operations, show our hardware, our setup, what basically we do, what hardware we use here. Currently we are in Belgium at ID2Move premises, so we are utilizing their test area. And basically ID2Move is a center of excellence, providing various like technologies and services for companies and for researchers. And there are different test areas: agricultural, military, like this field for flights, urban area, and so on, where you can test different sensors and different like technologies basically. And yeah, the idea for today's stream, we will of course, it's our first stream, let's say it like this, and something can go wrong, but we will try to manage with everything. And the idea for today's stream to show our mobile laboratory, which we usually take with us to our measurement campaigns, to show some drones from our drone fleet and just go through applications where they can be used. And then also show our new drone model, which we'll be using in our channel measurement campaigns. So basically our trip here to Belgium to ID2Move test area is dedicated to our future measurement campaign, our upcoming measurement campaign, related to measuring the radio properties between the air and ground. So we'll have like transmitter or receiver node on the drone and another node on the ground, and we will be measuring the channel properties. This is actually a joint project funded by National Science Foundation and Academy of Finland, and it's a joint project between NYU and VTT. So in the framework of that measurement campaign, we want to show this equipment, to give you an idea how it works, how we operate. But since it may be very difficult to show all the aspects of like, you know, our activities, we try to make it simple so that it kind of fits the stream. But of course, you're welcome to ask questions, and that would be really great if you ask them. And yeah, here is Jarkko. He will introduce himself.
Hello, I'm... Does my mic on?
Yes, your mic is on.
Hello, I'm Jarkko Saarinen. I work at VTT and I'm going to be the pilot for you today.
Yes, so now...
And camera operator.
Yes, so now we will just show you our mobile laboratory, basically. And this is, as you can see, this is how we usually go into the field operations. This is our van. So it's like we have all the equipment inside the van. We have 5G access point so that we can get internet connection everywhere. We have this awning providing us cover from the rain or sun, or if we have any other like equipment. Then basically we have, I can show you a little bit inside. Of course, we have the safety blinkers all around the van to show us or so that the car is visible. Inside, yeah, here it's quite basic setups. We have some office area, these 5G access points. We have batteries located under the seats and inverters providing us 220 volts, so we can also charge all the equipment while we are operating. And here, for example, we can see that as you may know, the batteries can be, also drones can be quite heavy, and all the payloads. So that's why we have this sliding platform where you can just put it out, put the batteries on it, and slide it back so that you don't damage your back. And of course, we have like a lot of spaces in the car, providing us additional like areas. So if you have remote control, you can put it here. So you can put any batteries here. So if the floor is dirty or wet, and for example, then in the corner over there, we have a heater which allows us to heat the whole trunk of the van, basically allowing us operations also in the winter time. So if you come in, you will see that we have like all the drawers here with all the tools, various tripods, various cables, so tools for maintaining the drones, changing the props, and for example, we have like spare parts here, like propellers, remote controls, and so on. Try to keep it organized so that everything is in its place. And here we have like our working area basically. So also with like some tools underneath and so on. And you have monitors. We have this 220 volts power supply, or it's also here, so that we can power all the electronics. We also use portable batteries to charge the drone batteries on the field. And of course some safety equipment. And if you come this way, so you see that we have here fire extinguisher, safety, road safety equipment. We have also, as I was mentioning, this kind of surfaces which we can put it this way, so we can have additional areas for putting the equipment, for example, and working with the equipment, and so on. So, and maybe I can show you also the van a little bit outside. So here we have, okay, besides VTT logo, we have these marks on the doors, for example. And those marks are usually used as a reference points. We have the same on the rooftop. And when you fly a drone, you can use these marks as a reference point for photogrammetry, for example, or even for locating your vehicle. We also have like roof racks on the top, so that additional antennas can be installed and so on. And basically we have also some signs on the rooftop for the car, so in order to easily locate it during operations or when we are on the field. So maybe, yeah, this is a little bit brief overview. So there is, of course, like you can see the ladder on the back. And this is brief overview of let's say, our van, which we utilize in our field measurement campaign. Maybe it's necessary to say that this is not all our equipment, of course. This is what we could bring to Belgium and what we are using here. And we have quite extensive capabilities in Finland as well. So we have another mobile laboratory. We have like trailers with equipment which we can tow to the fields, and we have weather stations and so on, so on. So it's kind of really, in terms of operating with drones, we are really capable to do any task, let's say. And now let's go quickly and check some drones. So it's just several models which we wanted to show you, which we bring here. And for example, this is DJI 300. Usually we use this drone for photogrammetry, or we have a LiDAR and we can put it as a payload, and then we can do the scans. And basically we have been using it here in Belgium already in order to get the LiDAR scan of the city environment where we will be performing channel measurement campaign. So currently we have this camera payload here, and also I would say that this drone is very good for teaching new pilots. So once we get new pilots at VTT, we usually use this one for teaching because it's very stable. And basically it's quite easy to control, and it's not so affected by the wind, for example, as it can be with the smaller drone models. So this drone is M600. It's quite heavy lifting drone, so it can carry up to 6 kilogram payload. And earlier we have been using particularly this drone in our channel measurement campaigns, but since it's quite difficult to keep the payload weight quite low, and we had to add more and more stuff on the payload like batteries, computers and so on, we actually replaced it with a new drone model, which we will show you in a moment, or which we will be trying, or which we will be operating today and testing today basically. So it's actually will be the first time we fly that drone, but it's the first step and in preparation for the measurement campaign. And here you have Inspire drone. Usually this one is used to monitor like the measurement campaign or to do some filming. And the drone which Jarkko was flying is DJI Mavic Sign, which is pretty like nice, and it's an A1 category, so you can fly it in the cities and so on. So and that drone we usually use just for filming our measurement campaign. And yes, maybe this is like brief overview. So let's see, or let me know if you have questions in the chat. And meanwhile, we can show you actually the Aurelia drone, which we will be using for our measurement campaign. And meanwhile, Jarkko will start preparing it. We can check if there are any questions in the chat, or if you are interested already now, or if you want to learn something now. So we can go through that. But Jarkko will start like preparations for and checking all the nodes of the drone. So it should be like technically inspected. We should go through checklist. We have like our checklist, but we will show you just like very simple one, which is embedded into the flight controller, and just show it there. So, and also after maybe we perform these flights, and when we fly this drone, we can show you the RF payload which this drone will be carrying. So let Jarkko do the preparations, and it's fine. So yes, so now Jarkko is doing the preparations. Let me see if you have any questions. Barbecue. Yeah, that's a good one. We didn't take it with us, but yeah, I'm joking. Of course, it would be nice to have barbecue, but I think once we come to the field, there is usually no time to have barbecue and to have fun, even though we are having fun flying drones. So that's our choice. But yeah, that I think was only one for now. And Jarkko is checking like the propellers, because we have changed them. So he checks also if they're tightened, and he will do also checks like if there are any mechanical cracks or anything on the hull of the drone. This is basically what you should do before like every flight. And there is another question when we lift off. We lift off once Jarkko is finished with all the checks, and actually he will be flying the Aurelia drone and testing how it works, how it reacts to the controller, because we have not been flying it yet. But meanwhile, while Jarkko is doing that one, I will be actually flying DJI Mavic and showing you, or giving you some footage also from the air. So let's see. Okay, so now I'm going to power the drone. And we have like safety switch here, so we cannot arm the drone while we are nearby, and So now the safety switch is off. So we should be able to go through the checklist and basically check or see how we fly. So hopefully you can see a little bit, at least you get the idea. So you see the view from the camera on the remote control. Now it's just connecting, downloading the parameters and so on. And also searching for GPS, and basically once everything is connected like it is now, we will get the checklist, like pre-flight checklist, and which we should go through and check if the battery is inserted correctly, if probes are installed correctly, if you have GPS signal, and so on. This is quite simple checklist which we will use now, but and installed in this controller basically. And once we are done with all checklists, so we will be taking off. So it still takes some time, and maybe meanwhile I can show you. So we have, like, this is an airfield, and just on the rooftop of that building we have a weather station. So that weather station collects all the parameters like temperature, humidity, wind, and we get all the data so that we can check it before the flights, or if we do channel measurements, that we can also check all the data afterwards and combine it with our measurements, combine weather data with our measurements. So this is like simple checklist which you should have, or which you have on this remote controller, like hardware. So, and you acknowledge that like probes are mounted and secured, battery plugged, and so GPS is passed, sensors passed. We don't have any sensor now installed. And then radio control, we perform range test and like confirm. So we know that we have a good signal now from the remote control. Actually, we can see it also on the display. So now we continue the pre-flight checklist also. So about the like motors, mission. So we don't have any mission here, and also there is some question about this Q ground control station. So
It's still heating up.
so yes, we need to wait. It's a little bit colder today, and actually when we planned the stream, we thought that it would be quite warm and sunny day, but as you can see, it's very cloudy and very humid today. So and a little bit colder, so that's why the drone is warming up, and we are waiting for that one. So, but once we get everything fine, we will be taking off.
And if I can mention, it's after arming, so the propellers are turning. There's few spots of the checklist that we have to do when
Yes. Okay. So just so Jarko is piloting the Aurelia drone now, and he's performing all checks, whatever is necessary, and I can just fly around and show you how it looks like also from the air, or give you some idea about the aerial shots. So here we see the aerial view of the field where we are located, and the weather station which I was showing, also our van, and this prepared like landing pad for the drone basically. Yes, maybe meanwhile, yes, I can take a question, sure. If you can read it to me, thank you.
What deck controller are you using for filming?
What
Deck controller are we using for filming?
if the person means, like for the streaming setup, we are using this Atom Mini Pro ISO. So basically that one is used to get connection from all cameras, and that's where we can switch between the cameras basically. So I hope this answers the question. So let me know if it was that one, or if you wanted to know any other information.
I will spin the motors.
Sure.
Arming.
So now Jarko is testing the motors. So usually all these preparations, so it's like, of course there was a question when we are going to fly, but usually all these preparations are taking time, and we try to make it simple and fast, just to save time and show most interesting parts on the stream. But of course, it's unavoidable, and that's why anyway we have to go through these procedures every time we take off. So
I'm ready to take off.
okay, so then whenever you're ready, you can take
Yes.
off.
Arming. Taking off. Hovering.
So we have retractable landing kit on that drone. Whenever we have our RF payload on the bottom of the drone, we actually put the landing kit up, and basically we have like 360 field of view for our payload, so that we can rotate payload to different directions and so on.
Okay. What's the lead?
I'm going to the altitude of 20 meters, so that you have freedom to go left, right, and so on, and test the drone that way.
Yeah. All right.
So I'm at 20 meters.
Okay. Checking.
So now, let's say the purpose of this exercise also is to get familiar with the drone, to see that everything works as it should be, that everything is programmed as it should be, that it reacts properly and responds the commands of the pilot. And once we know that we can fly empty drone without any issues, then we can actually start attaching and using the payload on the drone. So let me know once you're done. I will come close to get a close shot.
Okay. I'm done.
Okay, I will come a little bit closer to the drone so that you can see it in action flying in the air. So this drone is octocopter. Actually it uses 8 motors, and it allows us actually to put quite heavy payloads. If I'm not mistaken, it's up to 8 or 8.5 kilograms of payload. And once we go through our RF payload, I will show you, and our current RF payload is around 6.5 kilograms.
Okay.
So you can land. I'm going away from your drone.
Disarming.
So this was, as you could see, the test flight of this drone. So now we have to check that everything is fine and everything is okay. And after that, we will switch and see the payload. And basically now I'm just showing you the whole view of the area where we are located with our van and basically the drone itself.
There's a question on YouTube.
Sure.
Do you control the UAV through 5G or standard radio?
Now we are using standard radio. We have options to control drones through the 5G network, but we are now not using it, so we are just using the standard radio, and because it's much easier for our measurement campaign. So it really depends like on the purpose of your flight. So Currently, we are not flying like far away, or we are not flying BVLOS. We are flying line of sight, so these standard radios is enough. And in addition, of course, you can have like 5G, 4G for as a backup link. So we are not using it here just to avoid any interference problem with our RF equipment. But in general, yes, we have that capability, and usually in our work we utilize that as well. Okay, I will land meanwhile the drone, and then we can check the RF payload.
There's another question.
Yes, let me land the drone, and then we can take that one before we go to any other setup. Okay, and
Someone is asking what is the goal, what is the mission of the flight?
so today the mission is to test the drone, that everything, all the hardware works, that we do not have issues flying empty drone. And then, as I was mentioning, we will be installing the RF payload on the drone. And then during the coming days, the mission would be actually to perform the radio channel measurements, obtain the data for obtain channel information, and use that data to basically to create the channel models, which is the basic block for any wireless system design. And maybe, okay, so Jarko is preparing the payload, but if you give me a second, I can show you. For example, here we have the data from our weather station, so we can see air pressure, temperature, humidity, wind speed, wind direction, and so on. And this usually information we utilize prior for the flights, but we also collect this information in order to be used later on. So I will come in a minute to show you the RF payload. But yeah, now you think now you can see the Aurelia drone there. But let's switch to this portable camera. And here is a payload. So here we have a gimbal. So it stabilizes our payload on 3 axes, and we put this gimbal actually under the drone. So then here we have an antenna array, as you can see here. So we have beam steering capabilities, and we have FPGA board, RF SOC board behind it, and also we have portable PC here, and power converters, and we have also the batteries, which is actually here. So what we do, we balance this equipment, we put this equipment on the drone, and as you can see, we have the second node exactly identical, let's say. We use one as transmitter and one as a receiver. In this particular case, this is a drone node, this will be receiving the signal, while the second one will be transmitting. So, and we put this transmitter node installed on the rooftop of the car, and then we have the second node installed on the drone, and then we fly drone, and basically we measure, or we receive signal with the drone with this antenna array. We receive what is transmitted from the ground, and based on that we can actually analyze and estimate various physical phenomena, propagation phenomena, like reflection, transmission, diffraction, and so on. And we are working at millimeter wave frequencies, so we want to establish high data rate communication, which would be quite viable or quite necessary for the drone, and or communication between drone and car. And that's actually the idea, to collect the data about the radio channel, because currently, like standard models or current standards, they are not calibrated for millimeter wave frequencies. And that's what we are doing. We are collecting the measurement information, the channel information, and basically based on that, we can develop channel models which would serve for wireless system design in the future. So, and if you think about the applications, it can be drone and car integration, or drone and, like, for example, emergency service, car integration. So when the drone can fly ahead of a car and provide like necessary information for for ambulance to avoid traffic congestions and so on. So in order to do that, we need high-speed, reliable communication link, and this is actually, with this equipment, we can analyze it and we can study what actually happens between the drone and the air. So this is maybe briefly discussing this equipment and our upcoming measurement campaign, where we will be using actually these nodes and flying this big drone with equipment installed on it. Yeah, okay. Jarko will install it now on the drone. So we may perform now one drone flight with this equipment, just to see how stable the drone is. But now we will not be doing any channel measurements, because this requires a little bit more time and a little bit more like setting up everything and so on. So I guess you may need help here.
Yes.
It's off. Okay.
And
Yep.
this one.
Yes. Yes.
And this
Now
one.
lock this one.
What?
Yeah, you should lock this one. Yes.
It's like pushing the
Yeah,
button.
no. Just the sticker. Oh, this one. Yeah.
It doesn't move.
The other way. No. Okay, you move it up.
It's solid.
So then it's probably not really inserted like into the lock.
Okay.
So just yeah. Yes, now it should be. Okay, now it's good.
Oh.
And we should lock all the motors, because we will not be. Great, help me to lift them back. Yes.
What's the legs?
Yes.
Okay. Do we have a?
So we should have, yes, payload locks here. Okay, this one is locked, this one is locked, this one you need to lock.
Where?
It's not so easy to access.
Yes. If you want to go to the other side, I will hold it.
Yep.
Okay. Now it's
Yes, now it should be locked. In all access.
okay.
Yes.
And it's holding there.
Are there any other questions in the chat? Okay, so now there will be another check round and preparations.
I will put one zip tie on.
Yes. So now we are just checking because it takes time to install the payload and so on. Now the motors on the gimbal on the payload are fixed, and we will be just testing how stable the drone is when we take off. I think we're approaching end of our stream, but I think we can do this. I'll show you this setup and this, and take one more time, and then probably we can take questions if there are any. Yeah, while Jarko is installing or doing final preparations, so on. So if you have questions, put them in the chat. I can take them right now. So we can have this Q&A session if you have any questions while Jarko is doing final preparations and finish the stream with the flight, basically.
I'm gonna power on.
Okay, maybe actually one thing came to my mind. Meanwhile, is Jarko doing preparations, so I wanted just to show you the user interface of the remote controller. This is DJI remote control, and this is what basically the pilot sees. I see the number of satellites, the signal, the battery levels, time left to fly, and then I can also put various safety options, for example, maximum altitude, distance from the drone, return to home altitude, and so on. And you can also put various settings for the remote controller itself, like a mode or camera settings, for example. You can put like whatever you want to, in which resolution you want to film, and so on. You can check the signals, the transmission signals of the remote controller in connection with the drone, and so on. And in safety features, you can do all the calibration necessary. You can enable, for example, obstacle avoidance sensors, and so on. So basically this is the information what is available usually for pilot, and which pilot is using during the flight, basically. So now I think Jarko is almost ready for taking off his Aurelia drone, so let's wait for him.
For this flight, heating.
Yeah, so the drone now is again, because we powered it off while installing the payload, now it's heating up again the batteries and the IMU unit, and once it's done, we will be taking off.
Heater temp low, 39.3 is less than 40.
So we are still now waiting for the batteries and everything to heat up.
And there's a question. What module is installed to the drone?
So what do you mean, the flight controller, or are you referring to our payload? So in our payload, it's we have RF SOC and antenna array there. If you're referring to the flight controller, now we have Orange Cube flight controller in this drone which we are testing.
Also, what's the range of your LOS measurements with this surveys?
So the range would be, we didn't yet test the range in the city environment. In open field, we made a preliminary test and we could get like easily like 300 meters at 60 gigahertz. That was like results of our previous test. But again, now we have some modifications in the setup and so on, so it may be a little bit different. So before the measurement campaign, we will be going through the range test, of course, in the open field.
And arming.
So now, yes, this is like from the ground level, basically. The remote controller takes the altitude from the ground or from the takeoff point, and it shows 3.7 meters. So if you fly in the mountains, you take off, it will be 0. But then, of course, you can go to minus altitude and so on. And what you see now on the remote controller, this is 3.7 meters. Basically, this is altitude of the Mavic drone. So as we can see, actually the drone, even with 6.5 kilogram payload, is quite stable.
Doing some slow movement.
So I think I will land my Mavic, so because I'm running out of battery on that drone, so we will use just another camera to show you.
I will slowly move it around.
Okay.
Because it's locked.
Okay, Jarko was just testing now the control of the drone, also like going left and right and so on.
And landing.
And now he will be landing.
Disarming.
Disarmed.
Okay, so and yes, basically this is what we wanted to show you. Just very brief overview of our operations. This is our like normal working day coming to the field and performing measurements tests with various drones in various projects and activities. And it was very nice to have all of you here and have nice questions. Let's see if you have any more questions, which we can take right now.
How do you stream the remote controller's view?
So basically now we have HDMI cables connected to the Atom remote control, and then this HDMI cable we have connection to the DJI RC. Basically, as you can see here, I can show you just on the camera actually. So we have this RC, and then there's HDMI cable coming to the switcher basically, and then there we can switch with the cameras. We use Sony Alpha, which is connected also by the HDMI cable, and then we use DJI Osmo, which is like portable camera and is connected by Wi-Fi to the tablet and basically to the switcher itself, so we can switch between the cameras.
There was someone asking 3.4 meters down from what point on?
Yeah, I think I tried to take that one. I think it was related to the drone height or altitude. So
Someone is saying no SORA.
I guess it's SORA, Specific Operation Risk Assessment. Yeah, okay, this is very nice comment or nice question. I think we will be taking it to the next stream on next time, because I think all this topic regarding like categories, flights, risk assessments, specific operation risk assessments, it requires a little bit more time. But just commenting your question here, we are in the test area, so we are operating in A3 category. We have, of course, emergency response plans and so on, but we are not doing SORA for particular these operations. But this is an interesting point, and maybe if there is interest in it, we can take it to the next stream. So let us know basically in the comments or in the chat or by the email if you would be interested to learn about this topic.
Nassim is asking, how long can you fly?
It depends on the drone batteries, of course, and on your payload. With DJI Mavic, which we have been filming or used for filming today, you can fly like, I don't know, 40 minutes, 35 minutes basically. With these bigger drones, it's usually flight time around 20-25 minutes. When you put heavy payload, the flight time decreases, so it may be like 15 minutes and so on. But of course, we are not flying usually the whole battery of the drone. We leave like, I know, around 30-35% left before we land, so that we have some margin for any maneuvers if we need to take and so on. So usually the flight time is a little bit shorter than like the maximum flight time.
Another question is, do you need to get a permission because there are civilians closer than 50 meters?
So as I was mentioning, so we are operating on the test in the test area, and this is Tempo D airspace, which is activated now. We have an OTAM, so basically we are allowed to perform operations in this area, in this field, even if we are closer to other people. And as I mentioned, like our operations today falls not into specific category, but yeah, into A3, with the difference that yes, we are in this area with the Tempo D activated. Yeah, I think that was really great to have you, and I mean, of course, big thanks to the team, because without them it would not be possible. Here is Emanuel, you see here, and also Jarko, who's our pilot for today for the big drone. But indeed, it was very nice to have all of you. So thanks for joining. It was, I hope it was a successful stream and you learned something and you got some new information and you enjoyed it. But otherwise, yeah, have a nice weekend and see you in the next streams.
See you.